We're going to do the sum of an arithmetic series. Now you'll notice that there is a word change here. There's series and there's sequence. A sequence is a bunch of numbers in order separated by commas, so you're looking just at the terms. This word series is implying that you're going to take these terms and add them all together. So the sequence is 5, 8, 11, 14. The series is 5 plus 8 plus 11 plus 14, etc. So just keep that in your head, what those two different words mean. So given this sequence, what is the sum of the first 200 terms? I don't want to do that. I don't want to have to write out all 200 terms and then add them manually in my calculator. That's a nightmare. So there must be a way to build a formula for this. And in the spirit of building formulas, let's scratch 200 here for a minute and let's go with the first 5 terms, because I think that's a little gentler. All right, so I need a symbol for sum. So I'm going to use an S, and I'm going to see that there are 5 terms. So I want the sum of the first 5 terms. Well, that would be 5 plus 8 plus 11 plus 14. And I need a 5th one here. It looks like they're going up by 3 each time. Okay. Now, I am not going to add those manually because I'm trying to use them to build a formula right now. Okay. I'm going to write this again, but just for fun, I'm going to write them in the opposite order. I'm going to start with 17, and then I'll add 14, and then I'll add 11, and then I'll add 8, and then I'll add 5. Well, why would I do that, you may be asking? Well, friends, if you add 17 and 5, you get 22. If you add 14 and 8, you get 22. If you add 11 and 11, you get 22. 8 and 14, we already knew was 22. 5 and 17 is already 22. And over here, because I'm adding this and this, 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 it will be equal to S5 plus S5, which gives you 2 of those. Okay. So how does that help you? Well, right now I have 2 sums of the first 5 terms are 1, 2, 3, 4, 5 sets of 22. Now you notice that this is 5, 1, 2, 3, 4, 5, because there are 5 of these, which means there are 5 of these because that's 5. So this thing here, that's actually your n. So in the future, we're going to be writing 200 there. This 22 here came from adding the first term to the last term in my sequence. So 22 was just 5 plus 17, which was term 1 plus term n, right? The last one. When this is a 5, that's a 5, that's a 5, 5 is the last one in your sequence. All right, well, if I want a formula that says the sum of the series is, I just have to get rid of this 2 here. So I divide both sides by 2, and there I have it. There's a formula for the sum of all those additions put together. And I only have to do 1 addition, 1 multiplication, 1 division, instead of having to add up potentially 200 numbers all at once. So this is a real time saver. All right, now in this particular example, I don't actually know what term 200 is. Well, I could do this two ways. I could actually get the value of term 200 using the formula from the general term of an arithmetic sequence video, which was the first term, which is 5, plus the jump, which is 3, multiplied by the number of terms, subtract 1. It's 3 times 199. That's 597. So the 200th term would be 602. Therefore, the sum of the first 200 terms would be 200, because there are 200 terms. The first term, which was 5. The last term, which was 602. All divided by 2. That's 200 multiplied by 607. 200 divided by 2 is 100, and 100 times 607 would be 60,700. So if I were to take the first 200 terms in this sequence that started at 5 and jumped by 3 each time, and I added them all up, they would add up to 60,700. And I got that answer without actually having to do that enormously obnoxious addition sequence. So having a general term and then a formula for the sum of a term really shortens up work if you're having to do this type of counting. So I'm going to clean this off, and we're going to try and actually shove this formula into this one so that you don't have to do everything in 2 steps. Okay. So I would like to take this term and I would like to put it here. So I'm going to make a few changes in my first line. First thing, instead of calling this term 1, I'm going to call it A, so it matches the other formula. And then the general term should be A plus D multiplied by n minus 1. Okay, so I have an A plus an A here. That's 2 A's. We're going to throw this n into the bracket. And I'm going to divide everything by 2. All right, so I've got a formula there that has all the pertinent pieces in there, so I can do things without having to do 2 steps. So suppose I have a sequence. I have an arithmetic sequence where A equals 3, D equals 10, and there are 52 terms. So that would be 3 plus 13 plus 23 plus 33, etc. for 52 terms. What's the sum of that sequence? Sorry, I misused that word there. What is the sum of that series? Well, I've got a formula there that just needs an a, a d, and an n value. So S, the sum of the first 52 terms would be 3 times 52 plus 52 terms jumping by 10, and 52 terms less 1. The 3 and 52 is 156. 52 times 10 is 520. Cut in half is 260. Yes, multiplied by 51. I'm going to get the calculator for that because I don't trust my brain this morning. 13260. And that plus 156 gives you 13,416. So with this particular version of the formula there, you're able to just quickly pop that information in and spit out a value. I'm going to clear this off and try a couple funny questions with these 3 formulas, and then you're good for the practice questions. So here's a monster of a paragraph. The first term of an arithmetic sequence is 8. The last term is 99. And the sum of the sequence is 749. How many terms are there? Now, I mean, you might be wondering, why on earth would you ever know this information? Well, this is like how mortgages work. Now, mortgages aren't arithmetic sequences; they're geometric sequences. So we'll get to that in a bit. But if you know how much of the loan you're paying on your first payment, and you know how much you're paying on your last payment, and the amount that you purchased the house for, like, all that information is known. What you don't know is how long is it going to take you to pay off the house. So this kind of question, while it may seem a bit artificial, that's actually a legitimate thing to ask based on the information you might have. So given this, I'm just going to write out what I know. I have the first term is 8, so that's T1. It's also A in these formulas, so I've got an 8 there. The last term is 99. Now, it doesn't tell you what number that term is, it's just the last one. So that's Tn. Some unknown term at the end of the sequence is 99. And I have that the sum of the sequence, again, I don't know how long it is, so it's just Sn, is 749. How many terms are there? Okay, well, if I look at this thing here, that has an Sn in it, and it has an N. And it has an A, so I've got that, but this one needs the jump. And because I don't know how many terms this is, I can't actually do that. I can't deduce the jump, I can't do anything. Also, if you think about it, even if I did know that, I would have an n times an n, which is an n squared, which would make this whole monster quadratic. I don't want to do that. So I'm going to go look at my other sum of a sequence, or sum of a series formula. I have Sn. I need that. I have term 1, I have term n, and 2, which has been erased there. It's just 2. So I have enough information to actually solve it with that one. So I'm going to start with my formula. Right, and my sum is 749. The number of terms I don't know. Term 1 is 8. Term n is 99. multiplied by 2. All right, so 749 multiplied by 2, we'll get that 2 out of the denominator. 8 plus 99 is 107. 749 times 2 is 1,498. So I take 1498 divided by 107, and I should get my n. 1498 divided by 107 gives me 14. So there must be 14 terms there. And that's a very encouraging answer because n, if you recall, n belongs to the integers. It's like double z there. So it has to be something that's nice and round with no decimal points. The mother of all arithmetic series questions here. Somehow, someone has figured out, perhaps carved in the side of an ancient tomb somewhere, that there is a series where the first 10 terms add up to 45, and the sum of the first 20 terms adds up to 1,590. And in order to unlock the mysteries of the universe, you just have to determine the sum of the first 30 terms. Okay, well, this piece of information here, that's S10, and it has a value of 445. This piece of information here is S20, and it has a value of 1,590. Whew. Okay, so I'm going to need to remember that the sum of an arithmetic series was the number of terms multiplied by the first term plus the number of terms multiplied by the difference between each term cut in half multiplied by n minus 1. I'm going to start filling stuff into this. For S10, I know that n is 10, so I'll have 10a, I don't know a, plus 10d over 2 multiplied by 10 minus 1, which is 9. So that's going to shorten up to 10a. 10 divided by 2 is 5, and 5 times 9 is 45d. And just to remind everyone, that thing was equal to 445. Now that equation doesn't help you because it has two variables in it. It's not actually solvable. So I'm going to try the other term. Maybe that will be different. 20 goes in for n, so I have 20a, 20d over 2, and 20 subtract 1 is 19. That'll shorten up as 20a's. 20 divided by 2 is 10, and 10 multiplied by 19 is 190 times the difference. And just to remind everyone, that added up to 1,590. This is also an equation with two variables in it, and you can't solve it. But I now have two equations with those same two variables. That is enough to restrict my degrees of freedom to actually have a solvable equation. So you have two algebra techniques to choose from, either the substitution method or the elimination method, in order to shove one of these equations into the other one so that you only have one letter to solve for. I'm going to use elimination because I like it better. So I need to look at my coefficients, and I need to scale one of these equations up so that I get a match. on the coefficients of one of the letters. So I don't know how I'm going to turn a 45 into a 90 through multiplication. It's not going to go cleanly. But if I take this line and double it, I'd have 20 A's and 20 A's. So I'm going to do that just below here. So 2 times 10 would be 20. 2 45s would be 90. And 2 times 445 is 890. And from there, I'm going to subtract this equation from that equation. I'll switch back to green, a bit easier to read. So 20 A's subtracts 20 A's gives me no A's. That has been eliminated. That's why this method is called the elimination method. 190 D's subtract 90 D's would be 100 D's. And 1,590 subtract 890 gives me 700. Divide both sides by 100, I get D is 7. So the only way for the sum of the first 10 terms to be 445 and the sum of the first 20 terms to be 1,590 is if each of those terms is increasing by 7 each time. Once I have a value for D, I can get a value for A by putting this number either here, or here, or here. Any place you like. I'm going to go with this top one, just for no apparent reason. So 10A plus 45D, which is 7, equals 445. So 10A would be 45 times 7. 280 and 35 is 315. Check that. 7 5s is 35, and 7 40s is 280. 280 and 35 is 315. Feel good about that on the second try. Subtract 315 from both sides. We get 10A is 130. Divide both sides by 10. The first term had to be 13. So now that I have the first term and the difference, I can actually calculate the sum of the first 30 terms. So S30 would be 30 multiplied by the A value plus 30 multiplied by the difference averaged over 2 multiplied by the number of terms less 1. So that would be 30 minus 1 is 29. 30 times 13 is 390. 30 divided by 2 is 15, and 15 multiplied by 7 would be 105. I'm just going to check that one. Oh, good. We're killing it today. All right. 390 plus 105 multiplied by 29. I'm not going to push my luck trying to do that one in my head. And 3045 plus 390 gives me 3435. So the sum of the first terms is 445. The sum of the first 20 terms is 1,590. Then the sum of the first 30 terms has to be 3,435. Okay. So that's pretty much everything you can do with the sum of an arithmetic series. So I think you are good for the practice problems.